So this is the first video about sample spaces. So it's broken into two parts. I'm going to do the first part in this video, and then there'll be a second video for the second part. All right, so before we start talking about sample space, we're just going to consider a situation. When you toss a coin, what happens, basically? There are two things that can happen when you toss a coin. So I have a coin here, all right? If I toss this coin, it's either going to land on this side or it's going to land on this side, all right? So on this side, where you see the shape of the head, we call that heads, and on the other side, we always call that tails, and this one has a funny picture on it, but sometimes they have the eagle on it. All right, so there are two things that can happen, two outcomes. It can either land on heads or it can land on tails. All right, when you roll a dice, all right, so here's a dice, and if I roll it, how many different things could possibly happen? All right, there's 6 outcomes because there are 6 sides. It can land on one of these 6 sides, all right? Each side has a different number, so it can land on the 1, the 2, the 3, the 4, the 5, or the 6. Okay, it can't land on 2 sides at the same time, so only one of those. All right, so we call what happens, all right, when we toss the coin or roll the die, we call that the outcome. Okay, and it's just the result of whatever action you do. All right, so the action here is tossing the coin, the action here is rolling the die. All right, well, if you take those outcomes, okay, then they are called the sample space, and you list all of them, all right, then the list of all those outcomes is called the sample space. It's the set of all the possible outcomes. And there are 2 types of sample spaces, or there are 2 ways to find the sample space. We're just going to look at one of them in this video. So we're going to look at the first one today. It's called just a list, and it sounds, and it's basically just what it sounds like. You're just going to write down, when you make a list, you write things down. You write down the individual outcomes. All right, so you'll be given an event, and then you have to figure out, okay, so what could happen in this outcome? Kind of like what we just, well, exactly what we just did here. So the sample space of tossing a coin is heads or tails. Those are the 2 things that can happen. All right, tree diagrams is another way to find the sample space, and we're going to look at those in the next video. All right, so let's look at the first example. Belinda went shopping for a new shirt. She could choose between 3 colors, red, blue, white, and white, and 3 styles: long sleeves, short sleeves, and tank tops. All right, so we want to create a sample space to identify all of the outcomes. All right, so knowing it could be one of these 3 colors and one of these 3 styles, then what are all the possibilities she could do? She could have gotten from her shirt. All right, so we're just going to make a list of all these things. So if she gets a red shirt, okay, it could be a red long sleeve shirt. It could be a red short sleeve shirt. Or it could be a red tank top. Okay, so those are all the possibilities if she picks a red shirt. Okay, but she's also got these other colors, blue and white. So if she picks blue, she could also get a blue long sleeve. I'm going to abbreviate, blue long sleeved, a blue short sleeved, or a blue tank top. Okay, so have I gotten all the possibilities yet? Nope. There's still one more color. There's white. So she could also get a white long sleeve, a white short sleeve, or a white tank top. All right, so now do I have all the possibilities? Yes, I've used all 3 colors, and I've used all 3 styles. Okay, so how many outcomes were there? Well, if we just count at how many we got, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can see that there are 9 outcomes. All right, this hint is for tree diagrams, which we'll look at tomorrow or in the next video. All right, well, with lists, the tricky part sometimes is that you think you have them all, but sometimes you miss them. And so is there a way to check yourself? Well, actually there is. It's called the counting principle. And the counting principle says if you multiply the number of possible outcomes for each event is like tossing the dice, or in this case, the event was the 3 types, 3 styles of shirts and the 3 colors of shirts. Okay, so if you multiply all those possible outcomes, then you can find the total possible outcomes. So the counting principle will tell you how many you should have. It doesn't tell you what they are. You'll still have to figure those out, but it'll tell you how many you should get. All right, so let's try it for this one we just did. There were how many colors? There were 3 colors. Okay, so we take our 3 colors and we multiply it, times our 3 styles. Okay, our 3 colors times our 3 styles, what do we get? We get 9 outcomes. All right, which is what we should have, all right? In our list, we came up with 9 possibilities. So 3 styles, 3 colors, 9 outcomes. All right, so what happens if we go back and we add the color black? Now how many outcomes would there be? All right, so if we add black to the possibilities to this list, all right, we're gonna have to have another group of shirts, all right? If we just wanna know how many though, then now how many colors are there? There's red, white, blue, and black. So that would be 4 colors. Okay, the styles didn't change, it's still 3 styles. All right, so 4 colors, 3 styles. If we multiply those together, we get what? 12 outcomes, so 12 outcomes. All right, we already know what 9 of them are, okay, because that's the list we got here. So what are the extra 3? Well, they're gonna be that black, long sleeve, black, short sleeve, and the black tank top. All right, so this, multiplying the number for each, tells you how many total you should have, okay? Really helpful. All right, let's look at the next example. Let's say you have to find all the combination of pizza crust and toppings, okay? Assume only 1 topping per pizza, and the types of crust are thick and thin, and the toppings are cheese, sausage, mushroom, and pepperoni. All right, so if we go ahead and start listing our types of pizza, then I get a thick pizza. I'm going to abbreviate K for thick. Then what kind of toppings can I get on my thick pizza? Okay, so remember just one topping per crust. So it could be thick and cheese. It could be thick and sausage, right? It could be thick and mushroom. Okay, or it could be thick with pepperoni. So I found all the possibilities. Nope, I haven't used the thin crust yet. So I have to go back and list all the possibilities now with thin. All right, so thin, I'm gonna use TN for thin. All right, so if I do thin, I could do thin with cheese. I could do thin with sausage. I could do thin with mushroom, or I could do thin with pepperoni. My N looks like an H, but I will. Okay, thin. All right, so thin with all the different types of toppings. Okay, so the question is how many outcomes were there? So if we count these up, 1, 2, 3, 4, 5, 6, 7, 8, we get 8. All right, but if we want to check to make sure we have all of them, all right, let's go back and look at the possibilities for each one. Okay, so how many possibilities are there for crusts? Well, there are 2 crusts, right? 2 crusts. And then what was the other thing that they had a choice about? The toppings. There were 4 toppings. Oops, I don't know why I did that. 4 toppings. All right, so if we do 2 crusts times 4 toppings, 2 times 4 is what? 8 outcomes. All right, which is what we got here. So did we find them all? Yes, we did. All right, let's look at the last example. Isabel's ice cream shop specializes in ice cream sundaes. You can choose one option in each category. So there are how many categories? Flavor, vanilla or chocolate, toppings, peanuts, bananas, or sprinkles, and then a drizzle of caramel or fudge. We want to find all the combinations of sundaes, and so we're going to use a list to find the sample space. And remember, the sample space is just a list of everything that could happen. All right, so we can start with the flavor. So we just need to pick a flavor. So if I start with vanilla, there's going to be a lot of V's, so I'm going to use a V for vanilla. And then I could get a vanilla with 1 topping. So if I choose a topping, I'll just start with peanuts. And then after I choose a topping, I can choose 1 drizzle. So I could do vanilla, peanuts, and then caramel. all right? And so then I have to go back and try again. So have I used up all my vanillas? Well, no, because I could also do vanilla, banana, and caramel. Okay, and then I have to go again. I could do vanilla, sprinkles, and caramels. All right, so am I done with vanilla? Well, no, because now I could do vanilla with all of these, but I haven't chosen the fudge yet, so I have to list all those too. So I could do vanilla, banana, fudge. Oh, sorry, vanilla peanut fudge. Or I could do vanilla peanut fudge, or I could do vanilla banana fudge. Or I could do vanilla sprinkle fudge. All right, so now have I used all the vanillas? Yeah, I think so. Okay, then I have to do the same thing, but only with chocolate this time. So now I'm going to choose a different flavor, chocolate, but I'm going to choose peanuts, one topping and one drizzle. Chocolate, peanut, and caramel. All right, or I can do chocolate, banana, and caramel. Or I can do chocolate, sprinkles, and caramel. All right, but I'm still not done because now I have to use fudge as a drizzle. All right, so I could do chocolate, peanut, and then fudge, or chocolate, banana, and fudge, and chocolate or sprinkles and fudge. Okay, so you can see that as I add more possibilities here, then this list gets a little more complicated because I have to kind of keep track of what I've already used, right? The tree diagram that we're going to look at later helps with this, but this is also when it's helpful to know the counting principle because now I can go back and just double check to make sure that I didn't forget anything, okay, which is easy to do when there's so many different ones going on. All right, so how many outcomes did we get? Let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got 12. Let's see if we're right. So we have to use, we have to multiply how many of each event times each other to find the total. So there were how many flavors? There were 2 flavors. Okay, but that's not all. There were 3 toppings. And then what else was there? There were 2 drizzles. All right, oops, you can't see that. Okay, so the counting principle says if I multiply all of these together, then I get the total number of outcomes. So 2 flavors times 3 toppings would be 6. 2 times 3 is 6. And then if I multiply that times 2, 6 times 2 is what? 12. 12 outcomes. All right, so is that what I got over here? Yes, it is. All right, so as long as I didn't repeat any of these, then I'm good. I have all 12 outcomes. All right, so sample space, again, is just a list of all the things that can happen. All right, an organized list of everything that can happen. And then the counting principle is a quick way to check to make sure you have all of the items in your sample space. And you get that by multiplying each of the number, or by multiplying the number of each event times each other until you get the total possible outcomes. Okay, I'll see you later.